Today I want to give a little bit of a talk on different ways of harvesting and evaluating data for existing ESDs. I'm not sure the status of other states, but Utah seems to be in a really good position anyway, from what I gather, that they've got a whole bunch of old range site descriptions that have already been completed, and now we're in the process of updating them to the new ecological site descriptions. Bottom one? Thank you. Okay, when I first got this position almost exactly a year ago, I was approached by Shane Green, who spoke with us earlier, and one of the first things that he wanted me to do was to gather and harvest data for every ESD in MLRA 34B. And I asked myself, holy cow, you know, where am I going to start? Luckily, I had some great resources there in Utah. Both Shane Green and Jamin Johansson were my mentors in helping develop this. And so they were throwing so much data at me and so many procedures that I was like, I got to write all this stuff down, I'm going to forget it. And so that's why I came up, and developed this. And I'd also like to emphasize that, this is a work in progress. Any input that any of y'all would like to give would be greatly appreciated. We just want to make this, the best document we can. One of the first things that Shane showed me is the hierarchical structure that he had created on the Salt Lake shared drive, where every MLRA in Utah had a folder, and underneath that folder, every ESD was listed by the ecological site ID, and then in every one of those folders, you see these corresponding folders. And for today's talk, I'm going to emphasize on the climate, analyzing the climate data, growth curve, your extent map or GIS, as well as the soil and physiographic features like Curtis had mentioned earlier. First, I'm going to start with developing ways to develop your extent map. In ArcMap, if you open Arc Toolbox and navigate to where you want your data saved, right-click and create a personal geodatabase. Go in there, click it, name it whatever you'd like to name it. Okay, then first thing you need to do is you got your soils data. With Utah, and I'm assuming other states that have a lot of initial soil surveys done, they'll have statewide or MLRA-wide soils databases and shape files. Web Soil Survey is a good place to go get those. What we're going to do here with this data is create an extent map. So what you do is go to your personal database, you right-click on it, and go to Import Multiple Tables, and you're going to navigate to the DBF file or Access Database file associated with that. And within that Access Database, there's a whole bunch of other tables associated with it. And for the purposes of today, in my efforts, I just select all those tables so you can bring all of those in. After you brought all of those tables in, you want to bring in the shape file of the soils. And like Utah, it has for every soil survey that has completed status, we have the shape file for that, and somebody has merged that together and created a big old shape file. Once you bring that in, this dialog box comes up. You want to navigate to where you have that shape file located at, and where your output is going to be, which is your personal geodatabase that you just created. And then you just name it whatever you want. And in this instance, I just named it State Soils. Okay, once you have those in, and you'll see the shapefile in your legend on the left side of ArcMap. Now you'll go back and hit the plus sign in ArcMap, and you want to bring in this co-eco class and component table. So after you bring those tables in, you want to right-click on the co-eco class table, and you do a relate. And what you end up doing here, you're going to relate that table to the component table based off the common attribute. Whoop, wrong one. Off the common attribute of COKI. And so you're going to bring these two tables that are a little bit different, and you're going to mesh them together based off common attributes. Next, you brought in the co-eco class table and the component table, and you just related those two tables. Now you want to relate the component table to your shapefile, or in this case it's a feature class because it's in a geodatabase. You're going to relate that component table to the state soils layer that you had brought in earlier. Okay, now you have all of those things related to each other. You can go to that co-eco class table and right-click on it and hit the selection button. And you want to, in this step, you're querying which ecological site you're wanting to analyze. And like I mentioned before, Shane wanted me to collect all this data for every ESD in 34B. So I go in there and you're going to select by attribute. You go in there, select your co-eco class, and then the ecological site ID number. And in this case, and I'm not for certain in other states, but in Utah, I found that when this data was initially entered, that 34XY was the old naming convention, but then they broke it up into 34B and A. The 34A is mostly up in Wyoming, 34B is mostly down in Utah. And so you need to make sure that you, really look and make sure that you get all of the ID numbers that you're looking for. Okay, after you do that, you're querying that ecological site that you want to work with. Once you've done that query, the co-eco class table will come up in ArcMap, and you hit the selection button down at the bottom, and it will show you every ESD that you, or of that ESD that you had queried. Okay, in this first step, now when I did the relates earlier, you're actually preparing the relate to happen, but you hadn't actually executed the relate. And so in this step, you go up to the top of the co-eco class table, and you go to the related tables, and you select that first relate that I did in the steps a couple of steps ago, and you'll be on the co-eco class table, and then when you hit that relate, it'll bring up the component table. And I have these 1, 2, and 3 here. I'll show you in the next slide what I'm getting at. So you first did the relate in the co-eco class table, and then you did your second relate in the component table, which was the relate between the component table and the feature class that you had brought into your project. Okay, now if you close those tables out, and your ArcMap screen will come up, and you'll see the shape files that are all highlighted that you had queried. And you'll end up doing an export, and you just want to do the selected features because those are the ones that you wanted to do. And you're going to export that into another file into the hierarchical structure that Shane had put together. And after you export that shape file, it's going to ask you if you want to bring that into your map, and you want to select yes. Okay, now at this point, you had just created this shapefile. You had used your state soil stuff to do all those relates. You have done your query on which ESD you wanted, and then you brought it into your map. Now you want to go to your co-eco class table again, and you want to export that co-eco class data that you just queried. You want to export that as a DBF, and when you do that, it'll end up showing up right there under your feature class, the 34 BY009. Next, you want to relate this new table that you just exported into your component table, or with your component table. And when you do this, you're going to be relating them on the common attribute of a COKI again. Now you'll do an export of that relate that you just did, and it'll bring in another table there below your feature class as well. Okay, at this point now, you want to join these three different items right here. And so you'll right click and do a join for this example. And I found it really good for me anyway that your naming conventions on what you're exporting helps me make sense of it all. And when you join this, you're going to be basing it off the common attribute of Mookie. After you do that, you want to join that feature class with your co-eco class table. And all this is doing is just bringing everything together so you can analyze data. So we've got these different tables, and they don't quite talk to each other unless you do these relates and joins. And so the whole process there ends up bringing you to this point. Anybody who's familiar with ArcMap, you can change the colors and everything however you want. And Shane had come up with the idea of doing a color gradient on these, so when you pull it up on the map, it's going to be these different colors based off the relative composition value of that ecological site within that particular map unit. And so when you pull it up, and I'm not sure, can you guys see that very well? See the different colors? So the reds are the ones where there's a high percentage of that particular map unit that has that ecological site you're working at, and the further away, the less percentage gets into the yellow colors. And this is how Utah and Shane has decided they want us to do our extent maps, so you can have the different colors for the different component relations. After you pull all that together, you save it as a PDF, save it in the folder structure that Shane had created, and that's step one of the process. Next, like Curtis had talked about, you need to analyze all your soil and physiographic data. I am not a NASAS whiz by any means. I'm pretty much an infant in it, so I've had my boss run these reports for me in NASAS that will bring in all of this data that you can open up in Excel and analyze. Okay, once you have that data from NASAS, you open it up in Excel and you paste it in there, and then you end up selecting a pivot table. I didn't even know what a pivot table was before I had this job, but it's pretty neat tool. For this example, there's all sorts of soil and physiographic features that you'll analyze. But just for this example, you have your fragments on the surface between 2 millimeters and 3 inches. And when you select that over here in this right column, it'll drop down in that area. And then you'll actually go to your component acres and you'll drag it down into that box. And Excel defaults at the total count of those attributes you're looking at, but we want the sum of the acres. And so you have to go in there and change that. And what this does, it gives, if you're like me, I'm very visual, and so you'll hit the pivot chart thing there, and it'll bring up this graph there that you can look at to analyze your data. And you want to make sure when you're doing this that you don't want to capture any outliers. You want to think about the central concept of that ESD that you're working with, and use that data to enter into ESIS. And then after that, you just repeat the process for every one of the soil and physiographic features that you need to analyze for ESIS. These are all of the soil and physiographic features that ESIS likes to, or has us enter in. So, when I first started doing this, every time I would go and start analyzing an ESD, I would go through that process that I just went through with you. And I had a pathways student helping me enter data, and obviously she's smarter at this than I am, and she's like, well, this is silly that I have to continually keep doing this process. So she actually created a template, an Excel template, and so now all you have to do is that raw data that you grab from NASA, so you just copy and paste that, into Excel, or open it in Excel, and it automatically generates all of the, ranges of information that you're looking for. Third step is summarizing the climate. How many in here actually deal in ESIS very much? Okay. This is, yet another section in ESIS that they want you to analyze. First step you want to do is, if your state, and I'm assuming everybody does, but they have a shape file of the location of every weather station within your state, and you want to bring that in to your ArcMap project and have it overlay over your feature classes. Once you have brought those in, you go up to the top of ArcMap and hit the selection, and you want to select by location. And if you're lucky, you'll have a bunch of weather stations on your ESD. Unfortunately, sometimes you don't. But you want to click your weather stations there, and your source layer is the actual ecological site shapefile or feature class that you're analyzing. And what we're doing here is saying, okay, how many of these weather stations are within that ecological site? And once you have determined that, okay, these, for this example, you see these ones were the ones that were within that ecological site or close proximity. One thing you want to take into consideration that if you come across where you don't have any of those weather stations in your ecological site, you can put a distance search on there, and you want to be careful when you do that, because if you get too far away from your ecological site, of course, you might not have accurate weather and comparable. You also want to take into consideration the possible altitude. I mean, you may have a weather station that's only 100 yards away or 1,000 yards away, but it might be 300, 500 feet higher in elevation. So you want to take those considerations into account too. Okay, now that you have your weather stations that you've identified that is good for your climate analysis, you go into the Western Region Climate Center and use that list that you populated and go in there and actually harvest that data. And I'm not sure exactly who came up with this climate summarizer. Is anybody? Curtis, do you know who? Okay, Michael Carpinelli. Okay, and he was out in New Mexico? Okay. Thank you, Sarah. This climate summarizer tool, I'm not going to go into great detail at all, because when you get this package, it has really good instructions for it. And so, what he shows here is when you're in that Western Region Climate Center, you just copy that raw data. And in this instance, it is moisture. This one is temperature. And this one is frost-free and freeze-free days. And you just simply copy that data, paste it in Excel, and it gives you a printout like this. So you have your ranges of temperature, ranges of precip, and then your frost-free and freeze-free days. And all that data you just manually enter into ESIS. Okay, so if you're in your analysis, you don't find any of the weather stations that fall within your ESD or within close proximity. So, I'm not sure who. I know Jamin Johansson had developed a PRISM tool. Everybody familiar with PRISM? No? All right. I'm not even sure exactly how to describe it, but it uses like a range of variation between weather stations and stuff like that to give you the data that you want. But if you don't have those weather stations within close proximity, you can go ahead and use this tool. Okay, when you're in ArcMap, you go to your Arc toolbox again, you right click and add a toolbox, and within those files that you've saved to your computer, this ESD extract toolbox will, that's what you want to bring into your toolbox so you can analyze. So to open that, you just double click it and opens it up, and then you'll navigate to that area that you had saved that to, and then you want to bring in the area that you want to analyze, and the other example is that ESD, that 009 that I was analyzing. And once it's done running, doing its thing, you just end up going to the summary table that it put into that folder that you'd saved it in. You take that table, open it, and then you copy and paste it into the summary table that comes with the download. And then once you end up doing that, it'll give you a very similar summary sheet as the climate summarizer gave you. Unfortunately, at this time, as far as I know, they haven't been able to get the data or run the program, however you want to say it, that will give you the frost-free and freeze-free days. So you'll have a gap in your data in ESIS in that situation. Okay, the growth curve, the last one I want to talk about. I had asked Shane how a lot of the growth curves were developed in the past, and he told me that just experienced range cons that have been out there, in the field, they had kind of came up with these growth curves. And Gail Dunn, who used to work for ARS, he's since passed away, but he developed this growth curve calculator, and it's got a lot of background data in it. I'm trying to think I can't remember the program that runs behind the Excel. I'll think of it in a minute. Okay, so once again, you're going to have to do a NASAS query, and the query that my supervisor had done for me was the MLRA 4 Bozeman query, and you'll just go in. I'm not going to go into great detail about the NASAS stuff, but you'll go and collect that data, and the data that is needed for this growth curve generator is your soil layer depth, the bulk density, percent clay, percent sand, AWC, and your hydrologic conductivity. The report that we pulled actually gives you the thickness of each horizon within that soil. The growth curve generator actually wants the bottom depth, so you do end up having to enter a little bit of data manually once you run this report and bring it into Excel. Once you have your report, you go in there and you do a Excel filter. I'm sure everybody's familiar with that, and you just select the soil that you're interested in. You go in there and look, which soil is this, and you just do an identify in ArcMap, and it tells you which soil you want to analyze, and you use that filter in Excel to isolate those. And once you perform the filter, of course, you can see that you have all your Rivola soils there that you want to analyze. I found it was helpful to open up a new worksheet in the bottom of ArcMap and just copy and paste the data that you need for this growth curve generator, just to clean things up. I also found it was helpful that for the different map units, so they're all Rivola, but you have different map units within your soil survey, and I just opened up once again another worksheet there just to isolate the different map units, just to analyze that. And you need to run this growth curve generator on each different map unit just to get your range of variation. Curtis, did you say that, or Sid, that all of this data or all these presentations are going to be available to the participants, or?
Yes, actually, that would be available.
Okay, great. And so, you know, with time at spare, you know, I'm not going to go into great detail, because just like the other tools, these things that have been, you know, generated have really good tutorials for them. But when you get this file, you can click on that, and there's a little presentation that you can watch on it. Then, you know, once again, once you run this growth curve generator, you put that data in the, you know, state office repository for that ecological site. And this is some graphical representations of what it ends up giving you. It also gives you the tabular data that you can enter into ESIS as well. Unfortunately, at this point, the tool that I've used in Utah, it's my understanding that that's the only one that has been created for this growth curve generator. But I think it'd be fairly simple, and I need to, you know, talk with people like Curtis, and I've been in contact with the ARS out of Fort Collins, that all we need to do is simply enter in each individual state's climate data, and this tool will work for everybody. With that, any questions or comments?